At the end of the day, we will conclude the NECOVERSE story by presenting you use case 1 results, immersive learning experience and beyond. Yeah. So first of all, thanks to Turku AMK, Merja, and Werner and Metaverse, Linksoft, Aurora and Ossi. Finpeda, I'm presenting Finpeda. I'm CEO Pasi Mattila, and Jorma Palo has worked with me in this project, and Tuteka and Alexi as well. My background, as our whole team background, is fully from education. Pedagogy, architecture and technology. How to combine those by creating also immersive environment, physical and virtual school environments. In this publication, I present the kind of lifespan of virtual worlds. 1990, about virtual worlds in first generation, they were mostly closed for single purpose. Then, year 2000 and onwards, we faced more scalable virtual worlds, and you can see some of those in this green area. Third generation, when worlds were application platforms mostly. And after this publication was done, then we have faced fourth generation. Our kids, youngsters, they are playing games like Fortnite. South Korea have very impressive AR, VR platforms. And Facebook published Meta, when all the environments were joined and called as Metaverse environment. So where we are heading or where we are going towards 5th generation virtual world, where in Finland we are creating national Metaverse strategies. AI, as we saw from previous presentation, is coming more and more into virtual world. We are creating 3D city models from where you can go inside the virtual worlds. So remote presence is still in the middle, then you go into virtual building, you do virtual training in simulations or real-time environments, and at the end you have 3D city or meta city or whole country or global immersive environment. IoT, smart city operation, digital twins, and also smart translation services are all part of this development. Now it would be good to have links of translation system with us as well here on the floor. So, can we transform our still 2D world into 3D immersive environment? So moving from home page to home space, where you, me, you, or we can work in a collaborative space, or train and learn together in collaborative space. And there you can see some examples we have done over the years, mainly in basic education, vocational education, and industry training. And as we discussed with Merja, that in industry training it's becoming more and more important in in-service training to learn some skills in immersive environments. This harvester environment was made more than 10 years ago. We have had emergency exit drills, hotel lobby training environments, and what is my job or what we do? We design new schools and learning environment. And here you can also use 3D as a tool for learning. And in this project we work with robot training environment, welding in our topic. And I will hand this microphone to Werner to tell about our project results.
So, how do you follow all that imagination and all that magic with science. I don't know, but I'm going to try. So yes, we created, all right, that's better. Universal robots. Okay, we are maybe not at the point yet where we can tell them, hey, I need a weld, just weld those two plates together for me, and they go ahead and do it. No, I'm afraid not. Will we get there in the future? Probably, but not right now. These universal robots, the use cases are absolutely growing at a mind-boggling rate. They are being used more often. They are being used more integratively in the industry and so forth. And in the welding industry is probably where it is most prolific. So what did we do? We created a learning platform where we can teach people how to program robots. Yes, they still need to be programmed. Sorry, that hasn't changed yet. Why do we then have to build this environment? Well, because to assign a robot simply for training purposes means that there needs to be a robot somewhere available for people to come and use. They take up space. They're expensive. People from abroad, internationally, cannot probably get to them. If they do receive the training, they probably cannot speak the language that they're being trained in, so they have difficulty understanding. Let's create a digital platform. A learning platform that teaches theory and allows people to practice with something of a digital twin of a universal robot. I'm not sure, is the video available here? If not, we can show, sorry, I'm just going to try the link. Something happens? Nothing happens.
Not found.
Not found. Okay. Virtual environment. One half, which is the Finpeda platform, where users can learn the theory, etc., for programming a robot. They also have an opportunity to interact with a 3D model of the robot, but because it is still on a web page flat screen, users do not get the true sense and dimension of the robot with which they are working. Once they have been in the theory platform, they then can move, when they've learned enough, they will move to a VR station where they'll put on the VR headset and program a robot with a tablet so they can hold it in their hand. The advantage in VR is that you can actually place the tablet in the air and work on it like it was just a touchpad. In real life, you have to actually hold it in your hand. Anyway, and what we try to do with all of these, with these environments that we've created, is that we try to check, do people firstly enjoy using the environment? And secondly, is this environment actually an effective teaching tool? So we said about the research. We had 2 iterations that we used. I see now that the design word is upside down. Oh, it doesn't matter. We used these 2 iterations. The first iteration is what I'm going to be reporting on now, but as I speak, we are currently running iteration 2, where we are going to compare our first results and our second results. But let's get first to the first result, or the first study. What we tried to do there is we measured how effective it was to work in group or to work solo. That's important to remember, because remember, at the end of the day, we are in a Metaverse environment, and we want to make sure that this actually is suitable for group training. One would think, well, hypothesis is, it's a robot, you use it by yourself, why would you want to train in group? So we said, well, let's just test that theory a little bit, let's test that hypothesis, and we also checked what kind of user experience people had with the environment. Once we had those results, then we said, okay, in those results from iteration 1, we had a test where users were very quickly exposed to a robot. These were users that had no experience whatsoever with training a robot. Within less than half an hour, they had to be able to do a task with a real robot. Of course, they were not that successful with the real robot. Wait, the results are coming. What we said then, okay, so for iteration 2, instead of giving them this very short exposure, we decided on a repeated measures design, where we give the users or the students a longer period with both platforms, and that's what we're busy measuring right now. In the third iteration, we're still deciding who and what we're going to measure, but this is iterative design. Results, they tell an interesting story. So let me take you through the results quickly. We had, sorry, yes, the mouse is, I have a pointer, hang on, that's better. Yeah, there we go. Okay, so I'm going to come around this way so I can see better where I'm pointing at. We had ungrouped, which is the orange bars, and we had the grouped. So these were people who worked in groups of 4 or 5, and these are participants who worked solo. We had about 25, sorry, it's not visible here, but we had about 25 people participate in the study. After the Finpeda platform, which was purely theoretical, remember please, only 15 minutes. There wasn't much time to do really anything. The confidence levels. So how confident did the participant feel that they would be able to use a real robot? After the Finpeda, interestingly, all the ungrouped, all the solo people were at least more confident than the group people. Okay, maybe that's to be expected. They were alone, they were testing, they were concentrated, nothing was distracting, nobody was talking to them about other things. So yes, I would expect that, that's fine. Flip-flop comes after the VR experience, where suddenly the group people become significantly, or maybe not significantly, at least in 2 instances, turning the robot on and moving the robot to the home position, they become more confident. The world turns upside down. Explanation for this, it might be that one person in the group, and we did observe it in several instances, that a person within the group got it. They understood how to program a robot, and they took charge and they explained it to the others who were maybe not quite there yet. As a result, those people in the peer-to-peer learning environment managed to get an added explanation. And please note, everything was done in the same language. Now imagine a multi-environment where we can have multiple languages all understood at the same time. We'll get there. I'm leading into something here. When we get to the real robot, after the real robot, no surprise, everybody gets more confident because now they've seen a real robot, they've touched the panel, they've seen it move. So there's no surprise that after a real robot, the confidences really go up. There are some explanations for the individual things. I'm not going to get into that now, but I think the story is simply that confidence gets higher quickly after VR in the groups, and you cannot, unfortunately, eliminate real robot training. But what we can do is we can make it significantly less. They do not need to spend all the time that they have with the real robot. They can prepare themselves for it. So what happened at the real robot? Well, before we get to the real robot, let's look at the user experiences. That's also important, right? This doesn't look very high. Please ignore the colors. It's a predefined toolkit, so that the color bars don't exactly get in the same place, and also the scaling was a little bit off in one of them. But the numbers are still correct. So for the Finpeda experience, even though it looks a little lower and overall it looks pretty low, keep in mind that the scale starts at -3. These bars could have also pointed down. That would have been bad. But they don't, they point upwards. So overall, the user experience seems and was quite positive. Yes, the hedonic quality of the VR was a little higher, that's true, simply because it was a new technology. These virtual environments still got a good, like I say, a very good user experience score, but VR got a little higher. Let's look at the scores at the real robot. So we scored the usage, and it was done according to a rubric that we designed and developed together with Tuteka, together with our robot teachers at TUAS. And it was about, I think, 10 or so different points that were scored, and people eventually got to a score out of 100. And we can see that more or less half the people managed to do something useful with the robot. They had half an hour from zero knowledge to being able to do something with one of these robots. What does it tell us? Well, it tells us that, there we go. We do have a platform that instills confidence to novice users, especially in peer-to-peer learning. It appears to be effective. From 0, within half an hour, to being able to use a robot, that's effective by my books. But what we do not have just yet, and we're working on it because we want to make sure that there is a streaming language service so that people can practice their peer-to-peer learning in a group environment internationally with access to a robot that they would otherwise not have access to. And Linksoft is very much a key partner in our next phase of research. In iteration 2, we have implemented pedagogy, where people can speak out loud to voice their struggles with what they're learning. We are recording that feedback. We can use that for deferred or debriefing purposes for later learning, and they can also help us to develop our system better by pointing out some usability factors or user experience issues that they may encounter. The real work comes when we get to iteration 3. We really would like to test this on an international scale where we can have the real-time streaming. We can have people talking from India in their Hindi language, people speaking in Finnish, people speaking in some African language, people speaking in English, and everything gets translated into something subtitled that other people can understand, that everybody can understand at the same time. That is truly the imagination and the wow and the magic that we're after. We'll get there. Okay, I'm not going to talk too much about this. This is the research that's currently happening, iteration 2. The only thing that I wanted to point out here was that we are doing, as you can see, longer periods, repeated measures. We are measuring their confidence after each session. We are also measuring their confidence after each VR phase. So there are 3 VR phases that they go through before they go to the real robot. And once they've been in the real robot, we are going to compare those results to see if spending more time with our platform will boost those. So the whole graph sits on the 70 to 80, 90, 100% capability of the real robot. Yeah, I think that was it from my side. We need to go back to the future now. So, Pasi, over to you.
Okay, thank you, Werner. And I always wonder that when you practice in like browser-based virtual environment or VR sets, how is the transfer effect when you work with the real robot? And that's we are trying to find out. And at the end, we are developing concept called Sense Urban. So you have like 3D city behind IoT learning platforms and then services at the top of it. So what do you need to develop smart education solutions? First, creating the model or 3D models, bringing learning content into environment, developing those simulations, what we have had now from TUAS environment, built-in collaboration in multi-user virtual worlds, and then truly work in 3D. And now I'm trying something extraordinary, because I'm always wondering that why we are still presenting in 2D environments when we could have 3D spaces. So we could show our slideshows or our kind of experience in real 3D environments, because this is what we do in these projects. So let's have a look how it could look like. Or this is kind of a presentation or conference or meeting or seminar environment what I'm showing. This is Seppo's computer, so I cannot expect that what is the end result. And now it has a download browser-based environment and this room. How can I take it? Skip this intro, and then I can move. I have another avatar there, so I logged in or I joined into environment by using my mobile phone. I could open voice connection and and wait a moment, I'll go to another place.
Okay, I thought
So,
no.
yeah, I could use also this, but I'm clicking inside teleport, and I'm going to go to presentation environment. We did this for Cityscape Global Riyadh last year, and then also Smart City Expo. So as you see, we would have had our immersive learning experience presentation also here in virtual 3D. Okay. Let's close it, and then thank you Business Finland, thank you all partners, and this was use case